now.
Okay,
Mm,
you guys heard that?
I
Yeah.
can, but
Okay, so what were you saying again, Benita?
um, I can't join from my laptop. I'm joining from my phone right now.
Okay, that's fine.
I don't know what's the ID. I tried with the last time, but it's not working.
Oh, I'll just go ahead, or just all of us. I guess we could just post it on an announcement in our groups, or we could also just post it on the group me, so it's easier for you to do it from there, if that's fine with you.
Me in my laptop, that's why. Yeah,
Yeah.
that's okay. Be from the phone too.
Okay, okay. And then I'm just gonna go ahead and open the floor if there's any questions over the homework that we could possibly go over.
Okay.
Or has anybody gotten that far in the homework?
I haven't gotten far enough to have a question.
There's some in 1.6, but I think once we start going over 1.6, I'll be fine.
Okay, okay. And then has anybody done 1.5? Because I was gonna ask a question about number 20.
Number 20. I'm pulling it up, see what it was. Number 20.
Mm-hmm.
There exists an X where X is greater than or equal to X squared. I believe there is, so it is a true statement, because if you put X equals 0, 0 is greater than or equal to 0 squared, which is 0. Same with 1.
But what if you do 2? It wouldn't make the statement true.
Yeah, so what it's looking at right there, it's the there exists an X, which means it's not true all the time, but there does exist. Whereas if you look at 19, it's for all X.
Oh, okay, okay. Yeah, because I'm just like, I don't think it's false, but something's telling me it's not, it is, and I just wrote false, so good thing I got that covered.
That's the way I read it. It's like, I know that is right there, like there exists such that this. There is some cases, but there's not going to be every case, like the for all is going to be, it has to work for every single case.
Yeah, because like I wrote it down. I'm not even lying. I don't know if you could like see that little tiny paper. Yeah, and then it's like all like in cursive. So I'm like, I know some professors they don't like it whenever you read in cursive. So I just had to write it all down in plain text. Yeah. Okay. Let me see. Let me go ahead and share my screen real quick. So excuse the mess, but this was like my data mining homework I was doing. Where did I put it? Here it goes. Okay, so there's 5 of us. We could do 3 to 4 slides each. And we could just assign Kelsey in the last couple of slides, and then she could just explain it through the discussion board so that she could get credit for that as well. That cool?
Yep.
Okay. All right. I'll start off with the first. Well, no, that doesn't count. With slides 2, 3, and 4. And then I'll give an example and then just go off from there. So then it's going to be me, Marina, Rocio, and Benita. Cool?
Yes.
Okay. Okay, so for this lesson, deductive reasoning, the process of drawing a conclusion from a sequence of propositions. So P1, P2, dot, dot, of Pn, which therefore Q is either true or false. So it's just a hypothesis. So in this example, the rule of inference modules ponens. So P then Q, but P, therefore Q is either true or false. So an example of this is basically, let me see. I'm just gonna give an example that I got from the homework. Or, you know what, let's say the snowing day today. So if it snows today, then you don't drive. Okay. Okay, so it snows, therefore you don't drive, right? True or false?
That'd be a true statement.
Yeah, because I'm not driving out there.
No, I have not left my house. My little brother goes outside to play in the snow. I'm like, yeah, no, I'm saying where it's warm.
Yeah, no, my dog, she's like, sometimes she still tugs me and I'm just like sliding off the ice though, and I'm like, no, and then I just see her like kind of slipping. But yeah. Okay, so the fallacy of affirming the conclusion. So basically, if it's an invalid statement saying that, let's say another example, I still want to use the snowing day.
Okay.
Let's see. Okay. If it snows today, then I will get into an accident. If it snows, therefore, let's say not Q, I don't get into an accident on a snowy day. It could be false because the ice might be icy, sleet, and you know how black ice is transparent. So that could be considered as a possible false statement. Cool. Okay. Marina.
Oh, let P of X be a statement involving the variable X and let D be a set. We call P a propositional function or predicate with respect to D. If for each X, I'm so sorry, what's that symbol called?
It means an element of
D, P of X is a proposition. We call D the domain of discourse of P. Sorry.
Yeah, just right here.
Let P of X the domain of discourse D, the statement for each X element of, I'm so sorry, you said element what?
Of D.
it means it's an element of.
Okay,
X
just element of D. P of X is said to be universally quantified statement. This is denoted by upside down AX, P of X. Okay, so it's called a universal quantifier.
It means that upside down A, it means for all X. That means in every case of X, it has to be true.
So like all real numbers squared will always be greater or equal to 0 in that example. Okay. And then let P of X with the domain of discourse D, the statement, there exists X elements of D, P of X, is said to be essentially quantified statement. This is denoted by extensional quantifier. Oh, sorry, I'm trying to read the example.
So every element of X, no.
There exists an X that is an element of a real number. So there exists an X that's a real number where X over X squared plus 1 is equal to 2/5. It's not going to be every single X, but there is an X that if you plug it in, is going to get you that.
So they're just saying it's somewhere out there.
It's
somewhere
get
you that answer. Okay.
Yeah. It might be just one case of it, but it's out there. That's what that backwards E means. It means that there exists an X.
Okay.
So that one of that
Getting
symbol
those
is
two
very
confused.
Only reason I remember is because right now I'm taking another class where we're doing proofs and he uses symbols a lot, and I wrote down all the symbols he's written so far.
It's like sometimes like I write it down and I'm just like, so for every element of X, wait, I'm like, wait, no, it's the other E.
Yeah. Upside down A is for all. So if you remember that A is for all,
Yeah.
Mm,
and then that backwards E, it means that there exists one. So there's like it exists, the E.
Somewhere out there.
Yeah. It's somewhere out there. We don't know, we might not know which one it is, but it's out there.
Yeah. Okay. Okay, so this is your call, Rocío. So we got this slide right here. This
Qualified
beautiful
statement.
slide.
The examples,
The what?
the essentially qualified statement example.
Yeah.
Okay. To do, let us write symbolically the statement, some birds cannot fly. Okay, I'm trying to think of how you would write that. I know for sure, like if you have like the X statement is birds. Oh, I think she did one in our lecture. I remember because it was the penguins. We brought examples out of birds and like I remember penguins was like a big answer.
Yeah.
Flamingos.
Yeah.
And ostriches and some chicken. We like I'm like I know this. I'm gonna go find out what kind of birds cannot fly.
Isn't it a flamingo?
Flamingo can't fly.
Yeah, flamingo, penguins, and whatnot.
Word right here.
Mhm.
I was grabbing it so I can write it. I usually have everything right next near me. So work on homework. So it's X. And now with me there is
I really do hate my neighbors right now.
there exists an X. There why don't we write it like X as birds that cannot fly? I know there's, you can write it as that backwards. I don't know if you can see it. That backwards E. So there exists an X for the domain of X or P of X, which is birds.
Okay.
Okay.
The same thing with the next one.
Mhm.
So our P of X is rock fan. And our P of X is a rock fan. Our X in this case would be that they love Led Zeppelin. And it's every, so it'll be that for all, it'll be that backwards A of X of P of X, like that. So there exists, I mean, for all rock bands, the love that Led Zeppelin.
Okay. Okay. This part right here.
Generalize De Morgan's laws for logic. Let P of X be a propositional function with the domain of discourse D. Then each pair of propositions below has the same truth tables. So the not of for all X, P of X is this going to be the same as there exists an X, not P of X. And then the second one, not there exists an X of P of X, and for all X, not P of X. So saying is these would be have the same truth to them. So the first one, that for that first one, I'm gonna want that first half of it is gonna say not every X is in a P of X, and then in the second part of it says that there exists in X where it's not in P of X in that domain of discourse. So kind of going back to like that example she had over with us with the birds.
Mm-hmm.
It'd be saying like that first part saying not all birds can fly, and that second statement is saying some birds cannot fly.
Mm-hmm.
So it's like they're said differently, but they mean the exact same thing.
Yeah.
That's what it's saying. There's and the second one, same thing.
It's just flipped around.
It's just flipped around, but it is the exact same thing. It's like saying two different things, but saying it's having different words to it.
Oh, yeah. Makes sense.
Mhm.
Okay, and then this last one, and then we'll switch over to Benita after this one.
Okay, so applying De Morgan's law, that's the one, right?
Oh,
Yeah,
well, yeah.
Applying right now because it's saying in my phone screen it is saying so tiny words. So I'm looking in my laptop.
Okay.
Okay, write the negation symbolically and in words of the statement. Some birds cannot fly. So some birds, that means it will be downward A, right? Downward A, and then P of X will be the birds that cannot fly. Is it the answer I'm getting is correct, or it should be downward A? And
So
yes.
isn't it not? And
Oh,
then,
first not? Oh yeah, I think.
yeah,
Not
because for
down.
this statement, it's cannot, so it's gonna be not for some. I can't remember if it's this one or the other one.
I think earlier we wrote it down as if
Yeah.
X is birds that cannot fly,
Uh-huh.
it's in the P of X is birds, it's gonna be there exists an X
Mm-hmm.
P of X.
So basically, like,
Like it'll be
Was
like
it-
if you go back to the slide before it where that number 2 is.
this one right here.
Yeah, it'll be I think following that example right there. Because writing is asking us to write the negation.
Mm-hmm.
So I think it's gonna be like that one right there.
Okay, so that'll be the negation for some birds cannot fly.
Mm-hmm.
And then as for the second part, applying the De Morgan's law.
Let us write the negation symbolically and in words of the statement. Every rock fan loves Led Zeppelin. So opposite E. First, I think we have to write. Yeah, opposite E, then X.
Mm-hmm.
Of PX, or
Yeah.
do we have to put the negation?
Yeah, so it's gonna be for every element of X, P of X. So the way that you said it was right.
It's kind of confusing to say like opposite E, downward A. Yeah, I
No
think.
worries. We're all on the same train here.
Yeah. It's easier to show the symbols than it is to try to explain what they look like.
I know,
Yeah,
I still go back to the book.
and
Okay, and then this one right here. I think
if
it's the
ev-
to do right symbolically.
for every real number X, if X is an integer, then X is a rational number. The number root 2 is not rational, therefore root 2 is not an integer.
Yeah,
Okay,
so they have to
so
write it in symbols for us.
mm,
That's what that paragraph says in symbols.
yeah, we're not just gonna read it. Or no, we're not gonna read it. I feel like that's too long. Unless you want to give it a shot, Rocio.
Reading the symbols?
Yeah, because I think you're a little bit better than any of us are right now. Help us out.
Okay. For every real X, well, it's the exact same thing. So say,
Okay.
so that for symbol, that downward A with the
Mhm.
X, that's saying, that's for every
X.
for every X. And since the X is an element of real number, so it's gonna be, so for every real number X.
Mhm.
Oh, sorry.
And
Shouldn't
then
take
there's
long.
that P of X, to the arrow to Q of X, that's the,
Mhm.
our P of X is gonna be X is an integer. Q of X is gonna be our, X is a rational number. And saying, so it's saying Q of square root of 2 is not rational. That's why that negation's in front of it. And then the therefore, the 3 dots, therefore square root of 2 is not an integer because our P of X was X is an integer. I know our time's about to go off, so like the timers, I saw the timer start to start. I'm like, oh no.
No, we're almost done basically. So I think 1, 2, 3. Yeah, so I'll leave these last 3 slides over to Kelsey so that she can work on, and we did good for today.
Yeah. We'll just
Okay.
let her know to just kind of go over them.
Yeah, okay, let me go ahead and stop recording.
Okay.
Pause share and bear with me. Okay.